All right. Thanks for all for coming to my talk. I made it in the title that I'm gonna do a be safer on a bike using a Xbox Kinect. It's not actually Kinect, but we will get to that part. But first, a remark. A question for all you guys: who ever had to convince someone that what you're making is not what they think there is? Raise your hands, please. Yes. So for the people, what I'm talking about is these are two things that might not be the same, but might look similar. The one is my proof of concept, and the other one should be a bomb, but those are not the same. I didn't want to have the discussion during customs to don't get too customs, so I only got this thing. No proof of concept with wires, but just the camera I got here. So by the way, who all thinks this is a bomb? All right, there are a couple of people in the room who think this is a bomb. This is not a bomb. This is a alarm clock, which you can defuse by cutting the wires. Very nice gadget. I don't think I have the wires for that. But all right, just let's give a little background of why I'm doing this or why I actually start doing this project. For what if everybody knows about what makes the Netherlands, we got a lot of DJs, we got a lot of drugs to endure those DJs, and it's part of Amsterdam, and we got a lot of bikes. It's quite a nuisance, actually. But if you look into the news, what is going on with all of those bikes is that there are a lot of problems with those bikes. At least if you look at the news for the last couple of years. And if you don't know Dutch, and it doesn't matter if you don't, but this actually translates to boomer having problems using an electronic device because mostly boomers on an e-bike. But is that fair? I mean, that's my assumption. I see those pictures, I get, all right, not a boomer, not using a device correctly. I looked into the hard stats of all of those messages. What they're saying is that the half of the cyclists in an accident were older than 55 years old, so that's the first boomer tick. It's almost half of those cyclist accidents were women, more than 55 years old. And there are more accidents on an electronic bike than there were before. So basically what I'm saying is I want to protect my mom. So that's why the reason why I'm doing this talk. Because I want to help her not get hurt on a bike. So our goal was to recognize dangers on the road before the cyclist even sees them or even sees that is a problem and assist them during the ride. We're not creating an autopilot for bikes. But we do a little bit, but we don't want to be the next Musk. I don't want to buy Twitter, for example. First, our project. What is a we? We are a couple of engineers working on different kind of projects. I'm from DataWorks. We're a consulting company, and we also have a lot of scientists because we have data scientists and data engineers. Those don't actually mix well together. We made it work, but that's a whole different story. Next step, what do we need? We need something that is or has a camera, something that can be powered by a USB, something that we can program, preferably on the device itself. We need something that the user that is actually using the device to see what is going on, and we need to influence the bike itself. And it needs to be something small. So thinking about, all right, a Kinect then. So how does it look like in the end if you put all of those pieces together? So here you have a normal guy with a Kinect on his bike. I don't know if you can see the picture, but let's hope so. He needs to be powered. So you got your battery. You need to have some programming power because you know this guy doesn't have any brain, so you need to supply him with it, and you need to control it with it. All of those parts together will make something like this. This is a demo purposes. I haven't built this itself. This is from the creators who made this particular device. I'm going to talk about this later. And it's actually a crate with all of these things together connected to a Raspberry Pi just to control this particular device. Quite nice. But then again, how are we gonna, if we're gonna combine all of this together, are there other projects on the market? Like I said, I don't want to be the next Musk, but if we're creating something that is already available, why are we doing this in any case? But there are some other projects. Smart Halo. I don't know if anybody knows what a Smart Halo is. Nobody knows? It's fine. It's a Kickstarter project. Really fun thing to do. It looks like that. It actually works like it should have been what we thought our project should look like. But there was a problem with it because it's now defunct. They couldn't get the funding for round 3, so they had to break everything down for the for the whole project. So they don't exist anymore. In the Netherlands, we have a company called VanMoof. It is a connected bike. They say it's a smart bike, but it's not smart enough, not for our purposes. And if you use Google to say, all right, give me what a smart bike is, well, in every case, Google is your friend, but in this case, it presents us with this. I don't think this is a smart bike for our goal. So yeah, not very helpful. So we are actually for a project on the bleeding edge for safety. Let's hope we get it right. So getting back to the Kinect, something from 2010. It's a low-resolution device. It has assisted execution. You need it. You need a Xbox to it, and it's quite large. We're living in 2022 now. This is an Oak D, which actually has everything what a Kinect has, but smaller. It has a high-resolution camera. It's 4K camera on board. You can do on-edge execution on it, and it's very small. I don't have the size comparison. I hit my luggage limit very fast, so Kinect is way larger than this thing is. But then again, why not do this separate? If you can create a device that you can have a webcam, you can have a stereo camera, and you can have a eye separate, so you can switch them out. But then again, those actually cost a lot. This device doesn't cost that much. It costs like 200 euros. Sorry, $200, which is a lot less if you buy them than if you buy them separate. Right, but in this case with this thing, this was a niche thing. You couldn't actually get one. We got lucky. We entered a competition. It's here. This doesn't run anymore, but you can see if they have another competition to get one of those devices. Because it's actually very fun to do. We got in a room and we got together and we thought about a couple of projects we wanted to do. Let me see. Oh yeah. All of those ideas we got were fine, I guess, but those weren't the things we wanted to actually do or wanted to work on. The one on the bottom, those were needed because we needed to convince our managers to put some time into all of this, what we're doing. All the other ones were fine, but like I said, our project with the bikes from the Netherlands was the most viable to do, actually. So, to give some talk about what this device actually runs on, this runs on Depth AI. Now, Depth AI is a large platform. Oh, sorry. It's a large platform which runs a complete set of. Let me get back to that. It runs a complete set of. It's a complete platform in which you can run your computer vision projects based on what you're doing, and it makes it easy for you to get to it. But I was showing you this picture. I got a new Mac, and this actually shows that if you're running Python and you're running a new device on a new Mac, it doesn't actually work, out of the box at least. And so this was some kind of issue I got with this thing. But I actually got it working. To give some insight on how you can approach this device from a Python perspective, by the way, it's called the Oak D. I don't know if everybody can read this properly. Let me see if I can highlight it. Yes. All right. At the beginning, we have the pipeline. Everything from the Oak D has a pipeline. You create from this pipeline, create a camera, the cam Rgb, and with that camera, you can have you have to have a set stream name, and there you create a loop, and this is the with device line, and there you can show it on the on your screen. Well, yeah, you can also take my word for it, but I can also show you to it. Let me zoom in a bit. So I have a couple of demos ready for this. For example, if I want to run the, let me get the right demo for this. Yes, for example, the Rgb Preview. So this actually uses the 4K camera. And let me check if it actually runs. This is probably the demo effect. Let me run it again. Yes, all right, cool. So this actually doesn't show you a lot because it's just a webcam, right? You can show you a picture with a webcam. This isn't that hard, you should say. But if you're looking at the code, for example, it is. Let me check if I got the right one. All right. Let me zoom in a bit. Is this readable for you guys? Or should I do it larger? All right. Like I said, you have to create from this pipeline. You have to create a cam RGB, a out RGB for the link you have to create. Here you can say set the stream name, set the preview size. I like it to full HD, and then create the loop in which you say, all right, get me from the device the output name and show it on screen. Well, that's fine. There are a lot of other things you can do with this. Let me check because yes. There is a lot of things that this thing actually can do. Like I've just shown you a webcam. Well, like I said, a webcam isn't that impressive, but it can also do stereo depth. What that is, I'm going to show you later on. It can also do 3D object localization. This is very interesting for us if you want to watch something in a 3D space. You can do object tracking. This is very interesting if you want to know what's coming in front of you. And you have on-device Python scripting. This last part is really tricky and a really fun thing to have because if you do this, we haven't got to this part yet. But if you do this, you don't need anything between it. I have it now connected to my laptop. But if you use the on-device Python scripting, you can just run the scripts on this device and connect everything to it. You just have to power it. So our first step would be we need to have some object detection. Now here you can see it can detect out of the box a truck, a bicycle, or dog. This isn't foolproof. I mean, in most cases this will work, but in some cases you will need to be creative on what you're seeing. Oh yeah, this was the demo. In case my demo was working, this is a shot from the room in the just outside of this room. These are all the things it could recognize. And if I have all of my demos set and I pray to my demo gods, I can show you actually that it works in a room like this. Let me check if I have the. I need to have this one, I guess. So it says here spatial tiny YOLO, which actually means that it uses the Yolo model. Yolo model is a model in which actually says you only look once. And here you can see, for the people in the front row, that it actually recognizes that there are people here in this room. Not everybody in the room, but I don't care about that. But it actually recognizes people in the room. And this is all working out of the box. I didn't need to import any model, any training data. So this is actually really nice that this actually works. So let me get back to my slides. These are all the things that it can recognize. For us, the most important things that are highlighted now, at least for in the Netherlands. I mean, if you are in a rural area, you might even get to recognize what a horse is or what an elephant or bear or zebra is. So we know what the object is that we're seeing. Now the next part will be the object localization. I've told you that it has well, I haven't told you about the stereo camera itself, but it has a stereo camera. I also have the demo available for the stereo depth, and that might be interesting to also show. Yeah, so this might get a more complicated bit, but let me go through the. Let me see if I got the right one. Yeah. Here you'll see that I'm creating two cameras, a mono camera left and a mono camera right, and this will create a stereo depth. With this, let me get back to these slides. With this, I can create a map of what the camera is actually seeing and references those points. And with that disparity map, I can actually see what object is in front of me or what's behind the other object itself. This actually works quite nice. I can use the other demo I just used, the Yolo version, and I can show you the depth map if it wants to show the depth map. All right, and here you can see this is actually what the camera sees itself. It sees objects in the room. It sees depth, and it shows you this by using colors. And I also have a different demo that shows a little bit more about depth actually. Let me see. I think that's this one. Oh yeah. So I made this demo because of there is a rendering way. It's called subpixel. It's here, and what it actually does is it will use the hardware in the camera to make it easier for the camera to have a more better view when objects are further, because now we're seeing a lot of noise in the background, as you can see here. To give some insight of what the camera is actually seeing, this is the left view and this is the right view. And with those actually next to each other, let me see if I can pull them. Oh, it doesn't want to do that. With those cameras, it makes the disparity map. But if I change the, let me see, because I know there I got a, let me see, there is a subpixel, and it says also here it's better actually for longer distances. So when I turn the subpixel on, it should be showing, well, in my demo it showed a lot less noise, but here you can see what the camera actually does. This isn't anything doing on my laptop itself. That will be easy, but this is already being doing on this device. If you feel it here, it has a heat sink on the back, and it's actually pretty hot now. But let me get back to my presentation. Oh yeah, I made backups for in case everything went wrong. But all right, so we now have the project. Because we have the software and the ID, we only need to add the hardware. For us, we made a hardware setup. We got the bike, we got the camera, we got a Pi, and we got the braking assistance. All of this is we're all using Python to control everything between all parts of it. And that's quite a hassle. Like I showed you before, that I'm getting the error on my Mac just by getting a new Mac, and it will change all of my workflow. Well, that is one part of the equation we had to solve. I showed you that we're using a Raspberry Pi. There are highly scientific reasons to use a Raspberry Pi. For example, I had it laying around. I found it in my dresser. I haven't used it in a while, and it was very small and cheap. And this is the reason actually why we're using this, because it's quite commonly used, and it actually works with our camera. So that was a really good thing for us. But our advice from our team: don't reuse a leftover image and just start over. I don't know if anybody worked with a Raspberry Pi. Can I see show of hands for people who worked with a Raspberry Pi? A couple of people. What we did is, when we started out this project, we had a Raspberry Pi lying around, and we used the leftover image that was just on the device. Don't do this. We got into a build problem. We actually had to have the nightly builds from a Debian distribution from it to get it working. So don't use it, because we tested out the day after with a new image, and it just worked out of the box. So, all right. To give some insight in what we're doing, in this case we have a car. This is our bike, for example, which has the Raspberry Pi on top of it. We have the camera attached, and we have some lights. Now this demo will actually show that we got it working, we got it linking together, that the lights will show up on the place where the bottle is coming from. And yeah, let me just show you it, because we now see red light means, all right, it's left from you, it's in the center of you, and it's from the right of you. Well, that we got this working was actually quite, because it's really a fickle thing to work with. we got it working. We were very glad to do this. We got everything connected. But in every project, what you're doing is that you get enthusiastic about stuff you're doing. So with us the same, but we got a little deep into the hole and nothing was actually working afterwards. And I was really bummed out because we were getting so far, and as you can see in the timestamp, quarter to 5, we got everything working, and a couple of hours later, nothing was actually working. And that's because we just got a little bit ahead of our problem. But get back to what we got from it. We got the actual. This is a demo of what we actually got from it to show that we're working on a collision demo. So we got a collision demo here. We have a bounding box, and where we see, all right, this is where you need to have a watch field for your collision damage. And this is actually we got actually pretty far with this because I'm not showing it, but we got it working with the lights and all. So we got a project and now it's working. But our problem is it does work, but the next step would be that we need more data from it. We got we got a lot of feedback from people that we showed this, and they all said, "All right, the next step, what you need to do is have it actually working. So that will be our next proof of concept. We got a proof of concept that it works on the table, but the next step would be get it working on a bike, and that we need more data. Does it cost a lot? Well, I just showed you the camera only costs like $200. But if you have a bike that's 3,000 euros, then $200 isn't. It's a extra option, and I don't think people, if you want to buy a bike that is 3,000 euros, I'm gonna think you're expecting everything is on it. And does this project have a future? Yes, and we're working on a release for this year, and that's where I'm talking. We need to have some. It's no longer a proof of concept. It's actually a viable thing, and we need to, we need to get ahead of us, and we need to get working, but we need more data. So that will be the next step for us to do. My question actually would be, should it look like this in the end? I hope we can get it a lot smaller than what we just presented, what I just presented, because this is something that it works, but it has to be nice, and this, in my case, isn't what I think is nice. We're looking at stuff like this. This is a GoPro holder. We can use this, but this is actually not what we're looking at. Maybe the next version of the Oak D. This is the Oak D Pro. Nice hardware. Don't know if you can add anything from it, but yeah, it is something we need. We need to see if it works for us. Maybe does it look like this? Yeah, you can see the question mark is a little bit shifted to the right. I think that's related to my font size. But should it look like this? Don't know. We're looking into what we can see and what we can do. Now I've been rushing through this like hell. I've tested this out. I've done this before in 15 minutes. But I want to thank you all for joining me on this particular presentation. Do you guys have any questions? Oh yes, I see a question in the back.
Yes, I have a question. So how does the distance detection works around in the nighttime or in a dark environment? Is it still as good as it is in the daytime, or does it still need more data for that?
A good question about relating to nighttime. What I told you about the Oak D Pro, that actually has IR infrared sensors on it, so you can actually use it in the dark. This one doesn't, so that would be an excellent excuse for me to get one of those. Thank you. Any other questions? No. All right. Cool. I just want to say two things to you guys. There's a couple of things I learned from this project. One of those things is join competitions. You might get a nice webcam out of it or a nice device like this. And this might be something that is stupid to say, but work together outside of work. Because the thing that I've noticed with the data scientists I've worked with is that those guys actually do know their stuff. Instead of me thinking, all right, they don't know how to program, for example. For me, I'm an engineer with a programming background. So when you see code that is being produced by a data scientist, you say, all right, what kind of child did this? But it is actually quite nice to work outside of work with those guys. Just get something working. Just plan something more ahead, more than we did. So yeah, this was my presentation. I'd like to thank you and see you all on the floor. And if you have any questions, you can come up to me. Thank you.